Hey everyone, Tectonic here. So when you think about renewable energy, what's the first thing that pops into your head? For most of us, it's probably those giant, majestic windmills dotting a hillside, or maybe massive fields of solar panels. And look, those are awesome and super important. But this isn't going to be your usual windmill story. We're going to dive into something way cooler, something happening just under the surface in our cities and even high up in the sky. Beneath the headlines and the familiar images, a quiet revolution is taking place. All around the world, brilliant engineers and inventors are looking at nature and asking, how can we do this better? Smarter? More elegantly? They're creating new energy technologies that are not only incredibly efficient but also beautifully designed, sometimes mimicking the very nature they're trying to preserve. These aren't just concepts, they are real, working prototypes and products that are quietly reshaping our world and redefining what's possible for clean energy. So today, we're going on a journey to explore 7 of the most mind-blowing energy innovations you've probably never heard of. We're talking about underwater kites, trees that generate power, and turbines that hum like a bird. It's going to be a wild ride. Now first, like always, be sure to hit the like button down below. It helps us out tremendously with the reach of this video. Thank you, let's get into it. Alright, first up, we're diving deep underwater. When we think of harnessing the power of the ocean, we usually picture massive, bulky turbines that need really strong, fast-moving currents to work. That's been the big limitation for tidal energy. You can only put them in a few specific places on Earth where the tides are just right. But what if you could generate power from slow-moving water? That's the exact problem a Swedish company called Minesto decided to tackle. And their solution is straight out of a sci-fi movie. They call it deep green, but I just call it an underwater kite. It's this incredible winged device that's tethered to the seabed. Now here's where the genius part comes in. Instead of just sitting there passively, this kite actively flies through the water. As the tidal stream flows, even a slow one, the kite is steered in a very specific figure-8 pattern. You know how a kite swoops and dives in the wind? It's the same principle, but applied underwater with incredible precision. This figure-8 motion is the secret sauce. By flying in this pattern, the kite accelerates and experiences a water flow that is several times faster than the actual speed of the current it's in. It's like when you're riding a bike and you pedal to go faster than the wind. The kite is creating its own amplified flow. This increased speed spins a small turbine located on the kite's body, which is what generates the electricity. It's a brilliant way to multiply the power of the water. So, what does this mean? It means we can suddenly unlock vast new areas of the ocean for clean energy production. We're no longer limited to those rare, high-flow hotspots. We can now look at places with slower, more predictable tidal streams and say, we can generate power here. This technology essentially expands the map of where tidal energy is viable, turning what was once a niche power source into a potentially massive global contributor. The design itself is also super elegant. It's relatively lightweight and small compared to traditional tidal turbines, which makes it easier to install and maintain. They can deploy these things without needing massive, specialized ships, which dramatically cuts down on costs. Minesto has tested these kites, which they call dragons, off the coast of the Faroe Islands, successfully feeding power into the national grid. It's a real-world demonstration of a truly game-changing idea. Think about it, a fleet of these underwater kites, silently soaring in figure-8s beneath the waves, harvesting energy from the gentle, predictable push and pull of the tides. It's a perfect example of working with nature, not against it. Instead of brute forcing a solution with a giant, heavy piece of steel, they used clever physics and an elegant design to achieve something that was previously thought to be impossible. That's the kind of engineering that gets me really excited. Okay, from the depths of the ocean, we're coming back on land and heading straight into the city. Urban environments are notoriously difficult for renewable energy. There's not a lot of space for solar farms and the wind is often chaotic and gusty, which isn't great for traditional turbines. But what if we could integrate power generation directly into the cityscape, in a way that's not just functional, but also beautiful? That's the idea behind the Wind Tree from a French company called New Wind. At first glance, you might just walk right past it and think it's a piece of modern art, a metal sculpture of a tree, and you wouldn't be wrong. But this tree is doing something incredible. Its leaves are actually tiny, vertically oriented wind turbines. There are dozens of them on each tree and they're designed to spin in even the slightest breeze. We're talking wind speeds as low as 2 meters per second or about 4.5 miles per hour, a speed at which a big, traditional turbine wouldn't even start moving. The magic is in the design of these little leaf turbines, which they call aeroleafs. They are lightweight, shaped like a curved leaf, and can capture wind from any direction. This is crucial for a city environment where wind swirls around buildings, creating unpredictable turbulence. The wind tree doesn't care which way the wind is blowing, it just quietly collects that energy from all directions at once. And I mean quietly. The blades spin in near silence, so you could have one of these in a park or a plaza without it making any noise. This completely changes the game for urban wind power. Instead of needing a massive, noisy structure, you have something that blends into the environment. It combines art, nature, and technology. Imagine a row of these lining a city street, powering the streetlights below them, or a small grove of them in a corporate courtyard, offsetting the building's energy consumption. It's a decentralized approach to power generation that brings it right to where it's needed most. Each tree can generate a modest amount of power, a few kilowatts, which isn't enough to power a skyscraper, but that's not the point. It's perfect for things like charging electric vehicles, powering public Wi-Fi hotspots, or lighting up a small building. It's about distributed generation, lots of small sources adding up to make a big difference. It also serves as a powerful visual statement about a city's commitment to sustainability. The team at New Wind spent years perfecting the design, making sure it was not only efficient but also durable and aesthetically pleasing. They see a future where energy infrastructure isn't hidden away, but is celebrated as part of our daily lives. The wind tree isn't just a power generator, it's a conversation starter. It makes people stop and think about where their energy comes from and how we can innovate to live more sustainably. It's a beautiful fusion of form and function. So, we've harnessed the power of water and wind, but what about the biggest power source of all, the sun? We all know about solar panels which convert sunlight into electricity, but what if you don't want electricity? What if you just want the actual real sunlight but you're stuck in a windowless room deep inside a building? This sounds like a weirdly specific problem, but a Japanese company called Himawari has an incredibly elegant solution for it. The name Himawari means sunflower in Japanese, and that's the perfect description for their system. It's a device that sits on your roof and, just like a sunflower, tracks the sun's movement across the sky all day long. It uses a collection of small hexagonal mirrors all arranged on a dome to capture and concentrate the sunlight. It's essentially a high-tech, sun-following mirror array. Now here's where it gets really cool. Once the sunlight is collected, the system doesn't convert it to electricity. Instead, it channels the raw, pure sunlight into a fiber optic cable. Think of it like a hose for light. This flexible cable can then be routed through the walls and ceilings of a building, just like electrical wiring. At the other end, you have a special luminaire, a light fixture, that releases the sunlight, illuminating the room with the real, full-spectrum light from outside. The effect is astonishing. You can be in a basement, a hospital room, or a deep office cubicle with no windows, and yet the room is filled with the natural, dynamic light of the sun. It's not the static, flat light from an LED bulb, it's the real thing. You can see the subtle changes as a cloud passes overhead. This has huge implications for human well-being. Studies have shown that access to natural light boosts mood, improves productivity, and helps regulate our circadian rhythms. Beyond the health benefits, there's a massive energy efficiency angle here. During the day, you're lighting large parts of a building with zero electricity. You're simply moving light from point A, the roof, to point B, the dark interior. This can dramatically reduce a building's electricity bill and its carbon footprint. It's a passive lighting system that is way more efficient than generating electricity with a solar panel and then using that electricity to power a light bulb. The Himawari system is a beautiful example of thinking differently about a problem. The problem isn't just a lack of light, it's a lack of sunlight. Instead of a complicated two-step conversion process, light to electricity, then electricity back to light, they just moved the light. It's so simple and direct. They've installed these systems in museums, offices, hospitals, and even homes, bringing the tangible feeling of sunshine to places it could never reach before. This technology redefines what a window can be. It doesn't have to be a hole in a wall anymore. It can be a fiber optic cable that delivers sunlight wherever you need it. It's a reminder that sometimes the most advanced solutions are the ones that simply work in harmony with nature, using technology not to replace it, but to extend its reach in a thoughtful and beneficial way. Okay, let's go back to wind power for a second. We've all seen those massive wind turbines, and they're great, but they have a fundamental limitation. They're stuck to the ground. The wind down here is good, but the wind way up there, we're talking hundreds of meters up, is much stronger and more consistent. So how do you get up there without building a ridiculously tall and expensive tower? Well, a German company called SkySails Power has an answer. You fly a giant kite. And when I say giant, I mean it. We're talking about massive, fully autonomous kites with a surface area of up to 120 square meters. These aren't the kites you fly at the beach. They are high-tech parafoils, similar to what a paraglider uses, but built for power generation. The system works with a ground station, which is basically a winch and a generator inside a standard shipping container. This makes the whole setup incredibly portable. Here's the two-phase process. First, the kite is launched, and it climbs to an altitude between 200 and 400 meters, way higher than a conventional wind turbine. Once it's up in the strong, stable winds, it begins the power generation phase. The kite flies in that familiar figure 8 or a circular pattern, just like the underwater kite we saw, which generates a massive amount of pull on the tether. This pull unwinds the tether from the winch on the ground, and that spinning winch is what drives the generator to produce electricity. But wait, you might be thinking, what happens when the tether is fully unwound? This is the clever part. Once it reaches its maximum length, the kite's flight angle is changed so it offers very little resistance to the wind. The system then uses a small fraction of the energy it just created to quickly reel the kite back in. This retraction phase uses way less energy than the power generation phase created. Then the cycle starts all over again. It's a continuous yo-yo motion of reeling out and reeling in. The advantages here are huge. First, you're tapping into a much better wind resource, which means you can generate more power, more consistently. Because you don't need a massive steel tower and foundation, the system uses up to 90% less material than a traditional turbine of the same power output. And because the whole thing fits in a container, you can deploy it anywhere. Remote communities, disaster relief sites, or temporary mining operations. It's mobile, on-demand wind power. SkySails has already proven this works. They've deployed these systems in places like Mauritius, providing clean power to the grid. This technology is a form of airborne wind energy, or AW, and it represents a radical new direction for the industry. It's a low-cost, low-impact way to access the immense power of high-altitude winds, which are one of the largest untapped renewable energy sources on the planet. It's another example of engineers looking at a problem, how to get higher, and not just building a taller tower, but completely rethinking the approach. Why build a rigid structure up into the wind when you can send a lightweight, dynamic flyer up there instead? It's flexible, it's mobile, and it's incredibly efficient. It's the kind of out-of-the-box thinking that will define the future of energy. Let's head back out to sea, but this time we're going way offshore, into the deep ocean where the winds are the strongest. Building traditional wind turbines in deep water is incredibly difficult and expensive. You need massive, complex floating platforms to keep them stable. But a Dutch company called Touchwind has developed a radical new design that might just solve this problem, a floating wind turbine with only one blade. Yes, you heard that right, one blade. It looks a bit strange at first, almost like something is missing. Traditional turbines have 3 blades for a reason. It helps with balance and stability. So how does this single blade design work? The turbine is mounted on a very small, lightweight floating buoy. The key innovation is that the entire structure, rotor, nacelle, and buoy, is designed to be self-aligning and to move with the wind. Here's how it works. The single large rotor blade is positioned downwind. As the wind blows, the entire floating platform orients itself automatically to face away from the wind, so it's always in the optimal position. There's no need for a complex and heavy yaw mechanism to turn the turbine into the wind, it just passively does it on its own. This drastically simplifies the design and reduces weight and cost, but the real genius is how it handles storms and high winds, which is the biggest challenge for offshore turbines. With a traditional turbine, when the wind gets too strong, you have to pitch the blades and hit the brakes to avoid damage. With the Touchwind turbine, as the wind speed increases, the whole mast just tilts backward. It leans into the storm. This tilting motion reduces the surface area facing the wind, automatically shedding the excess load and protecting the structure. It's a storm-adaptive design. This simple, passive system has enormous implications. Because the turbine is so much lighter and doesn't fight against the wind and waves, the floating platform it sits on can be much smaller and cheaper to build. Touchwind estimates their design could lead to cost savings of up to 30% or more compared to conventional floating wind turbines. That's a massive number that could make deep offshore wind power much more economically viable. They've been testing a land-based prototype and are now moving towards offshore testing. The design is so elegant in its simplicity. Instead of adding more complexity and more steel to fight the forces of nature, they created a design that yields to them like a reed bending in the wind. It's a principle from martial arts applied to massive-scale engineering. Don't resist the force, redirect it. This single-blade leaning turbine could be a key technology for unlocking the immense wind energy potential of the deep oceans. It's a testament to the idea that sometimes less is more. By removing components and embracing a more dynamic, flexible approach, Touchwind has created a solution that is not only more resilient but also significantly more affordable. It's a beautiful piece of engineering. We've seen turbines that look like trees and turbines with one blade. Now get ready for a turbine that doesn't spin at all. Instead, it flaps. Inspired by the incredibly efficient motion of a hummingbird's wings, a Tunisian company called Tyre Wind has created what they call the Hummingbird turbine. And it's a completely new take on capturing wind energy, especially in urban areas. Traditional rotating turbines, even the small ones, can be noisy and create vibrations, which makes them unsuitable for mounting directly on many buildings. They also pose a potential risk to birds. The Hummingbird turbine, however, operates on a totally different principle. It uses two vertical blades made of carbon fiber that move in a figure-8 motion, perfectly mimicking the way a hummingbird's wings beat to create lift. This flapping motion, known as biomimicry, is what makes it so special. It's a three-dimensional motion that is incredibly efficient at converting the kinetic energy of the wind into mechanical energy. The two wings sweep through the air, generating power on both the forward and backward strokes. This oscillation drives a system of gears and generators to produce electricity, and because there are no fast-spinning blades, the whole operation is virtually silent and much safer for wildlife. The design is specifically tailored for the challenges of urban environments. Its vertical orientation and flapping motion allow it to capture wind from any direction, just like some of the other city-focused designs we've seen. But its key advantage is its suitability for rooftops. The lack of noise and vibration means you can install these directly on top of apartment buildings or offices without disturbing the occupants. Imagine a row of these silently flapping wings on the edge of a skyscraper's roof, turning the turbulent winds that whip around tall buildings into a steady source of clean power for the building itself. Each unit is relatively small, but they can be linked together in a modular fashion to create a larger power-generating array. This makes the system scalable to the needs of different buildings. The team at Tyre Wind was fascinated by the aerodynamics of the Hummingbird, which can hover, fly backward, and perform incredible aerial maneuvers, all while using energy with remarkable efficiency. They applied those principles to create a machine that works in harmony with its surroundings. It's less of an industrial machine, and more of an electromechanical creature perched on the roof. This bio-inspired approach is a growing trend in engineering. Instead of reinventing the wheel, inventors are looking to nature's 3.8 billion years of research and development for solutions that are already optimized. The Hummingbird turbine is a perfect example. It's quiet, safe, efficient, and visually striking. It's another brilliant idea that could help us integrate renewable energy seamlessly into the fabric of our cities. For our final innovation, we're staying in the city to look at what might be the most unusual wind turbine of them all. It has no blades, no wings, and it doesn't spin on a central axis like a traditional turbine. It's a sphere. Developed by O Innovations, the O Wind turbine is a spherical device designed to capture the most difficult type of wind there is, the chaotic, multi-directional wind you find in dense urban environments. Picture the wind on a city balcony or in a narrow alleyway. It's not a steady stream, it's a swirling, tumbling mess coming from all directions at once. A traditional turbine is completely useless in these conditions. The O-Wind turbine, however, thrives on it. The sphere is covered in vents of different sizes. No matter which direction the wind hits it, horizontally, vertically, or anything in between, it enters these vents. The clever part is the internal geometry. Once the wind is inside the sphere, it's channeled in a way that forces the entire device to rotate around a single, fixed axis, regardless of the initial wind direction. It's a bit hard to visualize, but imagine blowing into a pinwheel from the side versus from the front. It still spins the same way. The O-wind uses complex fluid dynamics to achieve this on a three-dimensional scale. It turns chaotic, useless wind into smooth, predictable rotation. This omnidirectional capability is a total game-changer. It means you can generate power in places that were previously written off for wind energy. You can put these on apartment balconies, rooftops, or the sides of buildings. Because it's a simple, single-axis rotation, and the device is small and enclosed, it's quiet and safe. It's designed to be an accessible, plug-and-play solution for individuals living in cities. The idea was actually inspired by a NASA project, the Tumbleweed Mars rover, which was a large, inflatable ball designed to be blown across the Martian surface by the wind. The inventors of the O-wind turbine, Nicholas Orellana and Yassine Nourani, adapted that concept for energy generation here on Earth. Their design was so promising that it won the International James Dyson Award in 2018. The potential here is for truly democratized energy. Imagine if every apartment in a high-rise had one of these on its balcony, each one contributing a small amount of power to the grid or to that specific apartment. It's the ultimate form of decentralized power, harvesting an energy resource that is all around us in cities, but that we've never been able to effectively tap into before. The O-wind turbine is a brilliant example of identifying a very specific problem, chaotic urban wind, and designing a unique and elegant solution just for it. It doesn't try to be a one-size-fits-all solution. It's a specialist. And by solving this one tough problem, it opens up a whole new frontier for personal-scale renewable energy generation, empowering people to become producers, not just consumers, of energy. So from underwater kites flying in the ocean currents to flapping wings on our rooftops in spheres that catch chaotic city winds, it's clear that the future of energy is unfolding in the most unexpected and inspiring places. These innovations are more than just clever machines. They represent a fundamental shift in our thinking. We're moving away from the brute force, one-size-fits-all models of the past and toward a future of elegant, specialized solutions inspired by and integrated with the natural world. Each of these technologies shows us that the limitations we once took for granted are really just opportunities for innovation. Can't use slow currents? Make a kite that flies faster, no space in the city, disguise a turbine as a tree, can't get sunlight into a basement, pipe it in with fiber optics. These inventions are a powerful reminder that the answers are often right in front of us if we just look at the problem from a new angle. They redefine how we interact with nature and technology, blurring the lines between the built environment and the natural one. This is what the next wave of the energy revolution looks like. It's not just about being clean. It's about being smart, adaptable, and beautiful. It's about a world where power generation is seamlessly woven into the fabric of our lives. These ideas are out there, they are being developed, and they are challenging us to imagine a different kind of future. The question now is, are we ready to embrace them?